Question number 2 says that universal set. Now, you see this U here. This U means universal set. It says that a universal set is equal to X, such that minus 2 is less than or equal to X, and X is less than or equal to 9. Now, that's what the universal set says. Now, we're looking at set ranging from minus 2 is less than X, which means that X is greater than minus 2. So, for this statement, we are going to interpret it on the other side. Now, set Q says that, now we say that under this universal set, we have another set what? Q. You know what the universal set is? Universal set is just like the mother of the other set. Every other set is found inside the what? Universal set. That's the concept. So both Q and K, even this Z I see here, they're all part of the universal set. So it also says that this set Q is equal to X, such that X plus 1 over 2, so that X is X plus 1 over 2, where the value of X ranges from 0 is less than X and X is less than 8. I will interpret it. Then set K is equal to X, such that X is even numbers less than 10. And they went ahead to say show that Q union K prime is equal to Q prime intersection K prime. So we show that these are the same. Joseph went further to say that show that Q union Z intersection Q union K is equal to Q union Z intersection K. So the best way to solve this problem is we're going to be taking it bit by bit. Okay? Gradually. We know they rush this one. So first of all, let's interpret the first set. So let's interpret the first set. So solution. So solution. Now let's list the set U. Let's get the values for U. So U is equal to, alright, now U is equal to X, such that minus 2 is less than or equal to X. What does that mean? Minus 2 is less than or equal to X. What are the numbers less than X? They say minus 2 is less than or equal to X. That means that if minus 2 is less than or equal to X, it means that X is greater than or equal to minus 2. Flip it. Minus 2 is less than or equal to X. It means that we're looking at minus 2 and numbers greater than what? Minus 2. Okay? We're looking at minus 2 and numbers greater than what? Minus 2. Please know that. Now, let's look at first. So let's list them out. So it means that we're starting from minus 2. So first, the first linear will be minus 2. If X is less than or equal to 9, it means that we're looking for numbers that are less than 9. We're looking for 9 and numbers that are less than 9. X is less than or equal to 9. Numbers that is 9 or less than and equal to 9. So numbers greater than minus 2 is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the elements in the universal set from the question we are getting our U. Alright, so now we are getting our values for U. Now what next? The next thing we need to get here are our values for Q. Let's get our values for Q. Now, there's something peculiar about Q. Q says Q is equal to X. such that x over 1, such that x is x over 1 over 2. Now, we see that q, the values for q ranges from 0, which is less than x, and x is less than 8. If they say 0 is less than x, what does that mean? X is greater than 0, right? So we're looking for numbers that are greater than 0, right? And we say x is less than 8. We also look for numbers that are less than 8. Okay? So for q, the values for x in q are, please, okay, let me just do this first, so I don't confuse you. Alright, so this is for q. Now, values of x in set q are numbers greater than 0 and less than 8. List them out. Are 1, 2, 3, 4, 5, 6, 7. These are numbers that are greater than 0 and less than 8. Alright? Now, when we do this, the next thing now is to solve for x. Are you seeing it? Solve for x. That's the next task. So, step 2. Solve for set q. It's solve for set q. Alright, solve for set q. Now, to solve for set q, you see that formula that is there? X plus 1 over 2. We need to solve for all the values for x using all these 1, 2, 3, 4, and 5. So the first task is we put x as 1. Second task we put x as 2, x as 3 till we get to 7. So let's start. So x plus 1 over 2. So the first one we're going to put x as 1. So alright. So put x as equal to 1, comma. We put x as equal to 1, then it becomes 1 plus 1 over what? Which is equal to 2 over, which is equal to 1. So this is the first value for set q, 1. Now, so this is for 1. So let's go for 2. So let's go for 2. For 2, we go again. X plus 1 over 2, which is equal to what? 2 plus 1 over, which is equal to what? This is the second set. Second member of set Q. 3 over 2. So for 3, comma, x plus 1 over 2 is equal to 3 plus 1 over, which is equal to 4 over, which is equal to 2. So for 4, comma, x plus 1 over 2 is equal to 4 plus 1 over 2, which is equal to 5 over 2. So the next one is for 5. X plus 1 over 2 is equal to 5 plus 1 over 2, which is equal to 6 over 2, which is equal to what? 3. So for 6, x plus 1 over 2 is equal to 6 plus 1 over 2, which is equal to 7 over 2. Then for 7, x plus 1 over 2 is equal to 7 plus 1 over 2, which is equal to 8 over 2, which is equal to what? 4. So we have solved for the elements of Q. Okay? So now let us list the element of Q now. So set Q is equal to, so set Q is equal to, where do we start? We start from 1, comma, 3 over 2. Read that for me now. 2, comma, 5 over 2. 3. 7 over 2. 4. Thank you. So these are the elements of set Q. We're not done, no? We are not done. They told you to find something now. And this is your intersection, union, and all those stuff. We'll define each of them. I think this question carries about 17.5 marks. Yeah, I think it carries about 17.5 marks. So this is element Q. This was set Q. Now the last set there is set what? Set K, right? Now set K. Define K for me. Define the K for me. What does it mean? Okay. X is an even number less than. Now, this thing. You may be tempted to start with 2, right? Right? I want to observe something. Remember that we said that Q and K are all elements of U, right? Remember, right? And we said that U ranges from what? -2 to what? To 9, right? I want to think of something. 9 is less than 10. Of course. Now, if you look at it well, since K is an element of U, which is a inverse set, and they say that for K, they say that X is an even number less than 10. Look at -2 here. -2 is an even number, do you know? So it means that we have to begin with what? -2. We don't just leave it because K is a subset of U. Do you get it now? So we begin with -2. Yes. So even numbers, -2. Then 2, 4, 6, 8, right? That's all. 2, 4, 6, and 8, yeah. That's all. Alright. Now, we have gotten all the subsets. We have gotten Q, U, and K. So, next task. So that's question number what? Number 2 what? I, right? So 2I, find Q union K. So let's find Q union K. So Q union K is equal to. Now, you know what Q union K is? It's set. When you talk about union, in union, you are combining the elements of different sets without repeating their elements. That's what it means. This is an element of Q. Alright? Okay, I'm going to move it here because of space. I know they will not enter there. I think they will not enter there. So Q and K now. Let's combine the element in Q and the element of K without repeating any of them. Alright? So look at the element of Q. 1, 3 over 2, 2, 5 over 2, 3, 7 over 2, and 4. Elements of Q. Now look at the element of K. So now, when you are combining union, you have to start from the smallest to the biggest. So look at Q and K. K has minus 2. K also has what? 0. That should ring a bell. Alright? But Q starts on what? 1. So if you want to like this element, it begins what? Minus 2, comma. The next one is what? Then 1. 1 is here. What is the next number before 2? 3 over 2. Can you see it? 3 over 2. After 1, you have what? Next? 3 over what? 2. Comma. What's the next number we have? 2. Comma. Now after 2, what else do we have? 5 over 2. Comma. What else do we have? 3. Comma. We have what? 7 over 2. 4. Okay, 6 and 8. 4, comma, 6, comma, 8. So this is Q union K. This is Q union K. When you are writing union, please do not repeat the elements. Even though they are common in both of them, do not repeat them. Alright? So this is Q union K. Done. Now, in the question, is it Q union K by K for what? Q union K what? Prime. Okay, so that's why it's Q union K prime. Alright, so let us start. Numbers, what can you find in U? I've told you that if I'm saying this, it's good to write it down. What can you find in U that you cannot find in Q union K? What are the things, the numbers you can find in U that you cannot see in Q union K? So let us start, let's come down, let's start from somewhere. Can you see minus 2 in Q union K? Can you see minus 1? No, right? So I think it's what? Come again. Can you see 0? 1, 2, 3, 4, 5. Alright. 6, 7. What about 8? What about 9? So, and 9. So this is Q union K prime. Are you following? You didn't get it? Okay. But do you understand what Q union K, right? Yes. Now, let me just give you a formula. Let me just give you a simple formula. Although this is now Q union K prime is equal to U minus Q union K. Let's take it as a formula. U minus Q union K equals Q union K prime. Let's take it like that. Now, with this time, that should ring a bell to you, right? That means that you should cancel out every member of Q union K inside U. Okay? Cancel out every member of Q union K that's inside what? U. When you cancel it out, the remaining ones is the Q union K prime. That is it. Alright, next up. What else? Now they said we should find what? I've got to Q union K prime. What else? Let me go to the question. They said show that Q union K prime is equal to Q prime intersection K prime, right? So now the next thing we have to find is Q prime. Okay. So the next task is find Q prime. Now, what do you understand by Q prime? Q prime simply means that. So Q prime, let me write it as a formula. Q prime is equal to U minus Q. So these are the elements of Q here, right? Now, you see all these elements. We are going to compare it to here. Like we're going to find out what are the elements of Q that we can find in U. When we discover them, we cancel them out. Anyone left is Q prime. You get it? Alright. So what are the elements we have? Now let's start. Over here, elements we can find. 1 is there, so we cannot add 1. 3 over 2 is not over here. 2 is there. 4 is there. 3 is here. So let's say the whole numbers are all here. The whole numbers are all here. So now we have in for Q. Now what are the elements in Q that we have here? We have 1, 2, 3, and what? So it means that Q prime will include everything except for what? 1, 2, 3, and 4. So now we are going to list out all the elements in U except 1, 2, 3, and 4. Just like what we did the first one. Okay? So let's begin. Start. Minus. So now we have listed Q prime, okay? Now we have listed Q prime. Now the next task is to find what? K prime, right? K prime. So we find K prime. So K prime is equal to U minus K. So what are the factors? What are the elements we can have here? So the same. Let's apply the same concept, okay? The same concept. Let's say, look at this K. Anything that you can see in K that you can find here, we don't add it, we exclude it, okay? So let's look at what we have for K that we can see here. Now, in K, we have a minus 2 is there. 0 is there. 4, 6, and 8. Alright? So, we're not going to add these ones that we just got. Let's add the ones that we got already. So, we'll start from here. 1, 3, 5, 7, and 9. Alright. So these are the values of K prime. Alright, now they say we should find Q intersection, Q prime intersection what? K prime. So find Q prime intersection K prime. Now, do you know what this means? This means that look at Q prime and look at K prime. What is common between Q prime and K prime? What are the things that are common in Q prime and K prime? So I'm coming. Q prime intersection K prime is equal to the set of. So now what is common? Minus 1, 5, 7, and what? These are the common things, right? Yes. Then we close it. Now, we are almost done. So let us see if what you have done is correct. Alright? So now, remember the question said that we should show that what? Show that what? Q union K prime is equal to what? Q prime intersection what? That was the question said, right? Yes. So now, let us see if they are the same. So what is Q union K prime?
Minus 1, 5, 7, and 9.
So minus 1, 5, 7. 5, 7, and 9 is equal to what? Q prime intersection K prime, which is equal to what? Minus 1, 5, 7, and 9. Therefore, it is what? Correct or proved. Let's see what prove. Are you seeing it now? So for what I've done so far, Q union K prime is definitely equal to what? Q prime intersection. That's all. That is the answer to the question. Alright, so now they say we should show that set Q union set Z intersection K is equal to set Q union Z intersection set Q union K. Now, there's only one set we have not defined here, which is set what? No, we have defined set Q already now. Set Z, right? So, we have to list elements in set Z. Set Q already now. Set Z, right? So, we have to list elements in set Z. What is Z? What is Z? What are Z? What is a Z? Z what do you understand by it? Integers, right? Alright, okay, now Z are what? Integers. What are integers? I heard everything and more. What are integers? Positive or negative whole numbers. So simply integers are what? Whole numbers. Isn't it? Integers are whole numbers. So stop. Whole numbers can either be positive or negative. But they are different from natural numbers, right? Because natural numbers are all positive what? Integers. Do you get it? So now, we need to find set Z. We need to find set Z. Now, set Z, remember that set Z is also part of the universal set. We're still dealing with that universal, that's like one thing. So, in this universal set now, we want to pick out all the integers. Okay? So, we want to pick out all the integers. Now, if you look at the universal set already, everything in the universal set are integers, right? But we don't mind. We don't mind. Let's write it out. So Z set Z. Z means integers. Integers. Integers are positive or negative whole numbers. Okay? Alright, so set Z. Let's start set Z. Let's just set Z. So we have just everything is set U. What do we have? Minus 2. So these are the elements of set Z. What's the next task? The next task is to find what? Z intersection what? K. Okay? So let's find Z intersection K. So find Z intersection K. Now, remember that Z is same as the universal set. So set K is coming from the universal set. Can you remember? So we have already gotten our Z intersection K. Check. We have gotten it. Does that make sense? Because Z is the universal set. And K came from what? The universal set. So Z intersection K is something as what? K. For this case. So let us leave, but moreover, I will still list them out. So set Z intersection K is equal to what is similar between Z and K? We have clean set here, so just give the values. Okay. Minus 0, 2, 4, 6, and 8, which is something as what? K. Are you getting it? Alright. Now, the next task. Find. Now the same is Q union Z intersection K. Now Q union Z intersection K is same thing as Q union K. Remember, because Z intersection K is same thing as what? K. So moreover, I'll see like it. Find Q union Z intersection K. So if you go down here, they're equal to minus 2, 0, 1, 3 over 2, 2, 5 over 2, 3, 7 over 2, 4, 6, and 8. So that is Q union Z intersection K. Alright, we have done Q union Z intersection K. The next essay is what? Q union Z intersection Q union K. Now let's find Q union Z. So find Q union Z. Q union Z is simply means what is similar in Q and in Z. So let's get it. So Q union Z is equal to. Now check what is similar in Q. If I know, I'll write it out. Check on the question what is similar in Q that's also found in Z. Alright? Okay. Please start the value for Q for me.
1, 3 over 2, 5 over 2, 3, 7 over 2, 4.
That's all.
Yes.
Alright. So what is similar in Z and there's also found in they say it's union, not intersection. Now since they say it is union, we have to add the set of Z and the set of what? Q together, alright? And remember we don't do repetitions in union. So because of that, so we will find what are the things in Q and Z without repeating each other. So where is Z? This is my Z. Q starts from 1 and Z starts from minus 1. So minus 2 rather. So where do you start? So this is equal to what?
Minus
2,
minus 1,
0, comma. Then we have 1 in both of them. Then what next? 2. We have 3 over 2. Are you seeing it? So 3 over 2. What next again? 2. Then what again? 5 over. Then what next again? 3. What that again? 7 over 2. 4. Sorry. 4, 5, 6, 7, 8, and 9. So this is Q union Z. So they say to find Q union Z. Now, since you have found Q union Z, we need to find what? Q union K. We already have Q union K already now.
yes.
Q union K. Q union K is something as this. It's something as this, right? It's something as this. So, but regardless, let's see write it out since we're in class. So we find Q union K. So there are a lot of them. So Q union K is equal to, please just call it for me.
Minus 2, 0, 1, 3 over 2, 2, 5 over 2, 3, 7 over 2, 4, 6, and 8.
4, 6, and
8.
Alright, so that is Q union K, right? The next task is we need to find Q union Z intersection what? Q union K. So find Q union Z intersection Q union K. Q union Z, that means that look at Q union Z here. Look at Q union K here. Alright? What can you find in Q union Z that you can also find in Q union K? So, almost everything. Almost. So, it is equal to what? Minus what? No, they say intersection. Intersection. Okay? Minus 0. 4, 6, and 8. So this is Q union Z intersection Q union what? K, right? I've gotten it. Now, let's look. What does the question say? Q, show that what? Q union Z intersection K is equal to Q union Z intersection what? Q union K. So let us see if they are the same. So Q is union Z intersection K gave us what? This, right? Yes. So this. Now let's relate it to Q union Z intersection Q union K. So let's come here. Are they the same? Yes. Are they the same? Yes. So we can say therefore Q, what's the question again? Q union Z intersection K is equal to Q union Z intersection Q union K. So it is what? Proved. And that is our final answer.